Hello everyone, here we will introduce our paper, Modeling Inter-Class and Intra-Class Constraints in Novel Class Discovery. Our method focuses on the task of novel class discovery, namely NCD in short. NCD aims at learning a model that transfers the common knowledge from a class disjoint labeled dataset to another unlabeled dataset and discovers new classes within it. We found that the existing methods do not sufficiently take advantage of the essence of NCD setting. In this paper, we propose to model both inter-class and intra-class constraints in NCD based on the symmetric Kullback labeler divergence. We conduct extensive experiments on the popular benchmarks and successfully demonstrate that our method can establish a new state of the art. Firstly, we introduce the NCD task in detail. In NCD, our goal is to discover new classes in the unlabeled dataset, with the common knowledge transferred from the auxiliary labeled dataset. The task assumption, as well as the essence of NCD, is that the set of label categories is semantically related but non-overlapped with the set of unlabeled categories. Our motivation includes 2 points. The first one is that current single-stage based methods, such as YONO, overlook the disjoint characteristic between the two given datasets. Most current methods pay much attention to the semantic similarity between labeled data and unlabeled data, rather than the non-overlapped relationship. The second one is that some previous NCD methods have introduced data augmentation techniques to help improve the clustering accuracy when discovering novel classes. These methods utilize MSE as consistency regularization to constrain the representations, but it cannot achieve the desired effect. The purpose of the inter-class constraint is to enlarge the distance between each labeled sample and each unlabeled sample in a mini-batch. Meanwhile, we consider that the distance between any two probability distributions of different augmentation of the same image should be small, and propose the intra-class constraint to constrain the intra-relationship between a sample and its augmentations. Finally, in the end-to-end training process, we maximize the inter-class constraint and minimize the intra-class constraint simultaneously. We conduct our experiments on 3 benchmark datasets and partition them into 4 different dataset splits according to the number of classes contained in the labeled and unlabeled subsets. Following the literature, we use the average clustering accuracy to evaluate the performance, and we report the results under the both task-aware and task-agnostic evaluation protocols. In the task-aware protocol, we know whether an image is from the labeled subset or the unlabeled one. In contrast, in the task-agnostic protocol, we have no idea about such information. In ablation study, we first compare the proposed intra-class SKLD with MSE. From the results, we found that the intra-class SKLD has a slacker regularization than the MSE-based one, will bring a greater positive impact on the more difficult datasets or their splits. Then, we evaluate the effectiveness of the proposed inter-class and intra-class components. In summary, both inter-class and intra-class constraints are effective, and each of them can consistently boost the performance of the baseline. In particular, the inter-class SKLD constraint alone can gain more improvements than the intra-class SKLD constraint alone. We compare our proposed method with the current state-of-the-art methods on 4 popular benchmarks using task-aware and task-agnostic evaluation protocols respectively. As we can see, our proposed method outperforms the current works on all benchmarks, achieving the excellent comprehensive results. To better demonstrate the proposed method, we illustrate the TSNE visualization for all classes on CVPR 10. Our method distinguishes better on the unlabeled data, such as dog and horse, demonstrating that our method can learn more discriminative feature representations. To visually explain the effect of inter-class SKLD constraint, we add this constraint into UNOV2 to obtain a new Byron UNOV2 class. Next, we establish the confusion matrices between the two models. These results show that the proposed inter-class SKLD constraint can effectively distinguish unlabeled data from labeled data to help discovering new classes, and can be easily added into other single-stage-based NCD methods as a plug-and-play loss term. In conclusion, in this paper, we propose to model both inter-class and intra-class constraints built on the symmetric Kullback labeler divergence for NCD. We conduct extensive experiments on 4 popular benchmarks and show that our method could outperform the existing state-of-the-art methods by a large margin. Thanks for listening.